Hello, welcome everyone, welcome back to my channel. Well, today we are doing the seventh theorem, that is the seventh circle theorem, and let me tell you, this is one of the most important theorem in 5 markers and more like the heavy or the difficult question you will find from this theorem. You might have seen many questions in 5 marks and 4 marks, and that will be from this theorem, and especially its proof is very important. So we'll be looking into this theorem specifically and how we can prove, because they don't ask you directly that prove that this theorem, but the questions require the concepts that we are using to prove this theorem. So let me do that, but before that, I'm running GCSE booster classes, crash course classes at just £4 per hour, and the regular one, the regular classes, if you're looking for, then it's just £6 per hour. Or if you're looking for any subject from year 1 to A levels, just drop us an email at exactacademy@gmail.com. They are affordable classes. We are starting the test series from 22nd April for GCSE all the subjects. And also, if you're looking for mock papers or like the flashcards or the quick revision sheets, you can purchase. They are highly affordable. So you just need to email us at exactacademy@gmail.com. And also, if you are looking for the free worksheets and a few theory sheets, they are available at our website, which is www.exactacademy.com. So let me see this theorem. This theorem says tangents which meet at the same point are equal in length. I have already described what are tangents in my previous video. Tangents are basically the straight lines that touches the curve, or in this case the circle, at the single point. So you can clearly see we have two tangents. This is because this straight line is touching the circle at one point, and similarly this is also touching at one point. Now it says the tangents which meet at the same point are equal in length. That means these two tangents are clearly meeting at one common point, which is P. So their lengths are equal. Lengths are equal, that means this length, the point from where it's a tangent, where it's touching that circle to that common point, and here in this case we can say these two lengths are equal. So I can write, so these two straight lines are tangent at M and N. So I can say M to P is equals to M to N, and this is what this theorem says. Now let me see how we can prove it. So let me just name this one. This one is same. So we can see here we have two tangents, MO and NO, and O dash. Let me name this P. O dash is the center. Or if you think like O dash is a little complicated, so we can use another letter for this as well. So let me just name this P. I can change it to P. That would be simpler. Now what we have to do is we just need to join these two together. So I'm just joining this together. Let me join the center and the point at which this is tangent, that means MO, and similarly I'm connecting NO. So just a minute, like this. Now on applying the previous theorem, which is the angle between the tangent and radius is always 90 degrees, this will give me 90 degrees. This is 90 and this is 90. And also we just have to join these two together like this, so that we will be having two different triangles, the triangle MOP and triangle MON. So basically this will give me two triangles, triangle MOP. So I'm writing triangle MOP and triangle ONP. And if I'll be able to prove them, the congruent one, it would be easier for me to prove that NP is equals to PM. So we are just proving them congruent. And for that, we can clearly see that angle M is equals to n is equals to 90 degrees by the same theorem, which says that angle between the radius and tangent is always 90 degrees, and you have to write down this. So we can say angle between radius and tangent is always 90 degrees. Now, the next is this common chord, this one. OP is common in both of these triangles. So I can say OP is equals to PO, that is common side. And then this one, OM and ON are equal. Just stop, just pause the video right there and think, why is it so? Well, it's because they both are radius. So I can say that OM is equals to ON is equals to radius. And now we have RHS, that means right hypotenuse, which is this, and a side. So by RHS, this is basically, so by RHS, these two triangles are congruent. And if these two triangles are congruent, so because we know that the congruent triangles are those triangles where the corresponding angles and the corresponding sides are equal, that means clearly MP is equals to NP. MP is equals to NP because this is the corresponding side of these two triangles. And hence we prove that both of these value, that is the tangents, are going to be equal. So let me do one question on it to understand it better. Let we see this question. In this question, it says that MRN, that means this angle, is given as x degrees. Then we have to find MPN, that means this whole angle, and that too in terms of x, because obviously the real values are not given here, so it has to be in terms of x. So because we know this one, this angle is x, so this whole angle is going to be 2x. And why this going to be 2x? Because angle at the center is always twice at the circumference. So in solution, what I can write is, since MRN is x, therefore MON will be 2x. By same, angle at the center is always twice at the circumference. Now we have already proved that these two triangles are congruent, but still we have to prove it. So we can say simply that MP is equals to NP by circle theorem. MP is equals to NP by which circle theorem? Circle theorem which says that the two tangents meeting at a single point are always equal. So I can say MP is equals to NP because the latest tangent theorem, you have to write the entire theorem. It's very important. Also, we know OM is equals to ON, which is actually the radius, and OP is equals to PO, which is a common side. So by side congruency, there we were actually trying to prove MP equals NP. That's why we were using RHS. Here we can directly use SSS to prove these two triangles are congruent. And since these two triangles are congruent, so corresponding angles will be equal. That means if this whole is 2x, so they both are what? X and x. So like x and x. So I can say from here that because they are congruent, angle MOP is equals to PON is equals to x. The value of each will be x. And if each will be x, then I'll be applying, now we know this bx. So take this triangle only, this triangle, I can apply angle sum property. So I am applying angle sum property in triangle MOP. So in triangle MOP, I can say that 90 plus x plus the third angle, which is this angle, that is MPO. So plus MPO is equals to 180 degrees. So MPO will be 90 minus x. Similarly, the bottom one is a congruent. That means if this is 180 minus x, this is going to be 180 minus x as well. So OPN will also be equals to 90 minus x, and this total angle is actually MPN. MPO plus OPN is angle MPN. So 90 minus x plus 90 minus x, that is 180 minus 2x, will be the final angle, and that's your final answer. So basically that's it for today, and we will be continuing our last theorem and few questions in the next lecture. So that's it for today. Bye everyone. Take care.